Hi everyone, today I want to share the beginnings of a new project with you. The goal is to build a fully bidirectionally articulated robotic hand, or at least that's what I'm aiming for. Right now what you're seeing is a partially functional proof of concept, to my knowledge, novel implementation of an internally routed tendon-driven finger with 4 degrees of freedom. In this video, I'll explain the core concept, show what I've built so far, discuss some of the problems I've already run into, and outline how I plan to move forwards over the next few weeks. Here we have the finger assembled, but with the tendons not rooted. I want to try to show you how the routing works. We have 3 links where tendons are attached. These correspond to the first finger link, the second and the third. Here they can go from here to that's probably a bit much. We'll probably shorten that range of motion next time. But yeah, we have on these 3 links one continuous loop of, or a continuous string of dynamo with a knot, so it will stop here and we can put force on there. That's true for all 3 of the links. The routing, the routing from here goes through the link, around a free running pulley here, over again, around a free running pulley here, and then you might see it, there's pulleys, then around and through there, coming out these holes, and from there it will go through a Bowden tube to be actuated behind. This will also happen with the other side in kind of a mirrored way. This way, for all movement, when one tendon has to get longer, the other can go shorter. With this, the overall length of the tendons will stay actually constant over the whole movement. Okay, let me just route that through. Okay, I have now fully routed that first side and we can see it works. By pulling one side, by pulling at the one side, pulling at the other, it goes up, and we can actually control it quite well. Okay. The second link works quite similar, just goes around here and then also around there through a hole in the thing, exactly like the first one. Let me route that. This is now routed, and as the first side, the second works quite similar. Okay, now to the third joint. This comes out here, and that will be a bit hard to see. But in the center of that last knuckle joint, we have a hole And these 2 points are screws holding in free running pulleys in a slight angle. So this goes around underneath that pulley that is inside here, then around a small free running pulley like this. So it goes down, then around here and comes on. That obviously in the middle. So let me do that as well. Okay, we have now routed that third degree as well. Wait, let me get the other strings a bit nicer. Okay, so here we can now see that also here we can control that from here as well. And that's it with the routing. Now there is actually the point where I think that this is a novel new design. So we have these 3 sets of tendons, each controlling one link, but there is a link or a joint left, and that is this one. And this one we can actually control as well with what we already set up here. Give me a second. So if I'm now using these strings like pull here, pull there, it just moves the link as we've seen. But if I take both sides and pull on both strings of a side at the same time, the joint that is directly controlled doesn't move because we are not moving them towards each other, but it goes like this. And with that, we can actually control 3 fully bidirectional axes with only 4 tendons that have to go through the moving wrist with Bowden cables. I'm not 100% sure that that is, in a sense, better than what is normally done, but it might. Okay, from here, let me talk about a bit about the system. So for one, you're seeing it's obviously bigger than a human finger, and it's supposed to be like a robotic hand. That's by choice right now. This is printed in 2:1 just to make assembly easier and all of that. You might have seen, depending on how much I jumped over it or time-lapsed it, especially this knuckle joint that is in a sense this and this axis. There's really a lot of stuff in there, and routing was quite hard. If that would be half the size, I'm not sure if I even can do that. So we will have to see if I find a better way of routing it or if I'm redesigning the thing. We will see. And for the idea of this here is really short. So I would like to have the motor for this axis, which was this here, have that actually put in here directly. So it is then on a hand in the palm of the hand. If we are doing that for all these fingers, there's quite a lot of stuff that we, for one, don't have to put in the forearm. And as we don't need Bowden cables here, it again lessens the amount of cables that have to be subjected to the friction in Bowden cables. Another point to consider with this internally routed design is what I call parasitic movement. The links that are closer to the fingertips are routed over all subsequent joints. When these earlier joints move, the later ones will change their relative angle too. If I can put encoders in the relevant joints itself, a PID controller could magically take care of this. But I doubt I will be able to do that, so I will have to calculate this and correct for it in software. Let's talk about the problems I encountered with this design. I found two major ones. For one, the cable routing does not quite work. For big angles in this and this joint, I have a problem that the one side is routed over and under here. This is fine. But the mirrored side goes here, and you see a distance here. So that side loses contact with the pulley it is supposed to match on. So with that, we are losing this property of same size. That's bad. I think this can be solved by additional pulleys here, here, and here. Here, there's the same problem here. That should be relatively easy. The downside is that these two links will get longer and we have more parts. The second one is that the Bowden tubes deform under tension and create massive friction. As Bowden tubes, I used extension springs. These seem to slide off their length axis and pinch the tendon. So, what's next? I think at this point, getting a feel for different methods for the Bowden cables is the most pressing point. I intend to build a test device to get a feeling for that. I already have extension springs and PTFE tubing in different sizes for that. I'm also interested in multiple materials for the tendons itself. Finding the limits for tension and the friction losses at these tensions will help inform future design. I think that's it for today. This project will take quite a while, so if you are interested in following it, please subscribe to be informed of my next uploads. And if you liked it, please leave a like as well. See you next time.